Today we're covering a topic that I'm really excited about. It's the anniversary of one of the most historic events in our nation's history and really the world's history. It's the anniversary of the moon landing. On July 20th, 1969, we landed on the moon, and astronauts Neil Armstrong and Buzz Aldrin actually walked on the moon. So we have two guests today, which I'm really excited about to kind of dive into this monumental event. I would love it if each of you could introduce yourself, where you work, and really kind of what your role is there. Michelle, we can start with you.
Great, yes. I'm Dr. Michelle Thaller. I'm actually an astrophysicist, and I work at NASA's Goddard Space Flight Center. So I've worked at the Jet Propulsion Laboratory as well at Caltech, and now I'm on the East Coast at Goddard. I've worked at NASA headquarters. I'm a scientist, but I also specialize in science communication.
Great, great. And Eric, you and I have talked before, but why don't you just introduce yourself again for everyone?
Hi, I'm Eric Gregerson. I'm the senior editor for astronomy and space exploration at Encyclopaedia Britannica.
Awesome, great. I can't think of two better experts to talk about this with. Michelle, we'll start with you. The space race really started from the Cold War and our competition with Russia. My first question is really, did everyone working at NASA, the engineers, the scientists, the astronomers, did they feel that competition the rest of the world did?
Well, I'm pretty sure the answer is yes. I mean, it's not that people were isolated from that. It's true that was maybe perhaps at the higher levels of the government. The real political goal of Apollo was to impress the Russians and to win the space race. I think that once NASA engineers get shown a problem that meaty and that wonderful, they really kind of dig in, despite the politics, and say this is an incredible problem to solve. And the thing that I'm kind of proud about as far as the American space program, a lot of people remember that Sputnik had been launched a couple years before. Everybody was sort of panicked that the Russians were way ahead of us. And sort of almost kind of ironically, a couple years after Sputnik, there was supposed to be this international year of space exploration where people began launching scientific satellites. And the United States was preparing for that. And in fact, our first satellite, Explorer 1, the very first thing that we ever launched into space, was not just a political stunt. It actually had interesting science on it. And so from the beginning, the American space program was a little bit different in the sense that science was supposed to be included on pretty much everything. But as far as, the larger space race and the environment of the time, I'm sure at the very least, the NASA managers felt that very keenly.
Great, great. And Eric, we landed on the moon in 1969, but this really all started in 1961 with President Kennedy's famous speech where he really challenged us to complete this task.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
What were some of the biggest obstacles, or what were some of the initial things that NASA really had to figure out before focusing on landing on the moon?
Pretty much the whole darn thing of how to land on the moon, because in 1961, when Kennedy gave his speech, the U.S. had not even launched a human into orbit at that point. They had just had one suborbital flight of 15 minutes under their belt. So surviving in space for 15 minutes is a lot different than sending people to the moon and bringing them back, which was days. And nearly every piece of that puzzle had to be figured out. Docking in space. When the lunar module went down to the surface, the astronauts had to come back up and dock back with the command module again. There were other things that were not known about the moon. There were some theories, what if the moon was just like quicksand? Every piece of the puzzle was a complete unknown and had to be figured out. There was nothing they could rely on other than rockets put things into space. That was pretty much the only thing they had figured out.
That's the only thing they knew. Michelle, to piggyback on that, figuring out all these unknowns, the training must have been, that you must have also had to go back to the drawing board with the training. So what were some of the hardest parts of the training that they had to kind of figure out and also, actually do?
Well, I mean, I know that one of the things that was really exciting was the whole idea of actually practicing for the lunar landing and how risky that really was. And a lot of this was done at Langley Space Center in Virginia, where they actually had these flying platforms that Neil Armstrong was actually trying to balance out and land and all of that. And they would do this at night, so there was a little more of a realistic look of the mock-up of the lunar surface that they had. Very stark shadows and all of that. I remember when after they got Neil Armstrong back and they asked him how the whole thing worked, he said, "Hey, it looked a lot like Langley, so we whether they were all doing that." So, I mean, just as has been said, I mean, the whole idea of living, surviving, and working in space was something that had to be worked out from the beginning. I know Buzz Aldrin, who was one of course, the second person on the moon, really worked a lot of the problems using bungee cords and resistance and trying to figure out how you could effectively work in a low gravity environment. And the thing that's really kind of amazing is how little you can really effectively test these things on Earth. So you had very, very limited time to try to actually practice these things, get all of these protocols down. I mean, it's to this day when we do something like land on Mars, one of the things people forget is we can't practice the landing in an Earth environment because Mars has different gravity, different air pressure, different temperature, all of that. So, when we're landing something, I mean, we've tested every part of it, but end to end, you can't really do it until you're in space. And so the rigor of the training, but also the tremendous risks these people took on is something that's tremendously inspiring to this day.
And that actually leads to my next question, Eric. Before Apollo 11, there were a lot of other missions, as Michelle she mentioned a few of them. Out of all those missions, what was probably the one that really was most important to be successful in order to support 11? And there may not be one, but I'm just wondering if there was one that everyone was like, this really has to go well in order for us to move to the next stage.
I think a lot of people would pick Apollo 8, which was the first Saturn V mission with the astronauts on it, as Michelle just mentioned. But I'm going to be a little bit different and say Apollo 10, because that was a dress rehearsal for Apollo 11, where they did everything but actually land on the moon itself. But I should say about the missions before Apollo 11, there was a distinct sequence where every mission was testing a key piece of the hardware. So Apollo 7, which was the first crewed mission, was the test of the command module and service module in Earth orbit. Apollo 8 was the first crewed test of the Saturn V and the first flight around the moon. Apollo 9 was the first test of the lunar module in Earth orbit. And as I just said, Apollo 10 was everything but actually touching down on the moon. So the lunar module actually did separate from the command module, go down a few miles and come back. And so when Apollo 11 happened, everything but the actual touchdown had actually already been done.
We've gone through all of those missions, Michelle, and now we're finally at Apollo 11. Takeoff was successful, and they're close to the moon. Could you kind of walk us through some of the, I know there's a lot of specifics that you could get into, but what were the basic steps that had to happen in order for it to be a successful landing?
Well, I mean, Michael Collins was going to stay up in the command module. The command module would then, separate off from the lunar lander module. The lander obviously would go down and come back up, reestablish itself with the command module. You ditch the lunar module, and then off you go back to the Earth. So, I mean, that sort of mission architecture was very simple and very well set out. But one of the problems that happened is just, I mean, quite literally, our knowledge of the moon wasn't very complete. And there were all kinds of little things that, had the possibility of throwing things off kilter. So, at that point, when the actual lunar lander separated from the command module, there was a little bit of gas pressure left in between the two that gave the lunar module a little bit more of a kick than they expected. And what that ended up doing is that they ended up a little bit downrange of where they were expecting to land. And we did not have very good maps of the lunar surface. I mean, we certainly had the best that we had. So they ended up in a rougher part of the moon than they expected. And there were large craters that were not on their map. And so Neil Armstrong in real time was trying to find a place to land safely because they'd overshot the original landing site. So, simple things like that they did not know exactly where each crater was. Certainly they knew where the bigger ones were, but ones that were, say, 10 feet across, 15 feet across, something you don't want to land on. In some cases, they didn't know that they existed at all.
Tranquility Base here. The Eagle has landed.
Once they landed, then there was a couple hours before they could open the hatch and actually get out on the moon. Well, how come they had to wait those couple hours?
Well, they first checked out to make sure the lunar module was okay. They also did things like try to establish where exactly they were on the moon. They also did a simulation of if they had to leave the moon immediately. And also, to get out of the lunar module itself, they had to depressurize the module, and they had to put on this 80-pound backpack. I looked at the checklist for that just a few minutes ago. That's like a 10-page long checklist of stuff to do to put it on that suit.
Houston, Roger, we copy, and we're standing by for your TEV. Okay, Neil, we can see you coming down the ladder now. Neil, we can see you coming. That's one small step for man, one giant leap for mankind.
Michelle, I wanted to know if you could kind of describe what the mood was like in the control center at NASA while all of this was happening.
One of the things that's very well documented is the moon landing. They had TV cameras, they had historians, they had all kinds of people working on it. I have gone through and watched, there's so many excellent specials that have been made about this. Things about how, nobody really wanted to applaud yet when they'd landed on the moon. Everybody was so relieved and so glad that was true. But the idea was don't celebrate until they're safely back on Earth. Until you see the whites of their eyes again, nobody start lighting up the cigars, which they did. They actually had cigars waiting for that. Interestingly enough, one of the things that I even learned, I didn't even know this as a NASA scientist, but I was watching a documentary. I noticed there was one woman actually at a major mission control desk. And I didn't realize there were any women that participated in that moment. And her name was Joanne Morgan, and she was an engineer. And in fact, her supervisors had to fight to get her in. I mean, and she was doing some ground system engineer work to support the mission. And even as a NASA person, I didn't even realize that there, in fact, was one woman there working as an engineer.
Wow, that's great. That's a good fact.
Yeah.
President Nixon actually had a speech prepared in case something went wrong. Were people nervous? I mean, I assume that everyone at NASA was focused and staying in their lanes and doing their job, but was there a sense of nervousness and insecurity of really what they were doing?
Well, of course. I mean, even now, it's a wonderfully, it seems kind of a simple statement to say, but I work for the communications office at NASA now, and people talk about, so what's going to happen if we have a bad day? So, with every launch, there's contingency plans as to who to call and what to do and what the statements are and what will be written. I mainly deal with the non-human side of NASA exploration, the robotic spacecraft. So certainly a bad day for us can be tragic, but not nearly as tragic as if it involves people. And so, I've never been a member of the astronaut communication office. I'm sure they also have statements ready. I believe you can see Nixon's speech.
Yeah, you can. I found it on one of the archive sites, so I'll put the link in the description below too. But it was really fascinating to read that, and I know he was nervous too because President Kennedy had given the challenge, but now Nixon was the president in order to see it through, and the amount of time and money and manpower that had been spent. But fortunately, everything went well.
I can't tell you how proud we all are of what you have done. For every American, this has to be the proudest day of our lives. And for people all over the world, I am sure that they too join with Americans in recognizing what an immense feat this is.
Can you each share some facts that people may not know about the mission?
Well, the one thing I was going to talk about was, and this is kind of a little topical for right now, is the astronauts did spend 3 weeks in quarantine after they came back from the moon. It was felt that it was unlikely, but nevertheless a small possibility. What if the astronauts bring back some pathogen from the moon? Yeah, they were in quarantine for 3 weeks afterwards. And actually, Armstrong even celebrated his birthday in quarantine.
There were so many other things about that mission. Things like as Neil Armstrong was getting into the lunar lander for the final time, he had this big backpack on, as we were saying. And as he was moving around, he actually clipped a switch and actually broke the switch. That was one of the switches used to actually launch them back up to the command module. So, famously, Buzz Aldrin had a pen that he kind of reached inside and made sure that he could make sure that the switch, that the circuit was closing. So, all these things they had to solve, and the brilliant engineers that they were. And, one of the things that I'm also very happy about, we mentioned that there was one woman in the control room, all of the women and the women of color and the people of color who were part of the Apollo program that you just didn't see. Very happy when movies like Hidden Figures came out, where you realize that there were, women of color who were mathematicians and who were calculators and were the computers of the day. They were called computers. And all of these people that contributed to that moment, and the fact that it was a far more diverse population than historically has been represented.
So Michelle, what's next? Is getting to Mars really, would that be the next moon landing?
Well, certainly. I mean, I think what I would like to see first for human exploration is I would like to see a sustained presence on the moon and in space before we attempt a Martian mission. I think that a lot of people wonder, hey, we went to the moon. Why didn't we just keep going on to Mars? The problems of a safe human launch, landing and return to Mars, it's a completely different project than the moon, a completely different set of problems and challenges. For one thing, Mars is a planet by itself. It's not orbiting us. So that means the planets only line up that allow you to get from one to the other every couple of years. So the astronauts will be on their own for years in a very, very harsh environment. Mars has more gravity than the moon. So, landing safely and taking off again is something that we have just never tried to do at that scale. I mean, so far on Mars, the only thing we've landed, the largest thing that we've landed is about the size of a small car. And, for people to be there for a year and be able to survive, there have to be lots and lots of things already waiting for them. There'd have to be an environment that was safe for them. And one of the things people don't realize is that when you go away from the Earth, you end up in the environment of our solar system that is actually not as friendly to life as right here on the Earth. The Earth has a protective magnetic field that protects us from the radiation and high energy particles from space. And so the astronauts on the moon were vulnerable to this. We were quite lucky as far as the timing that we did not have, for example, a very strong solar flare while the astronauts were on the surface of the moon. If they had been exposed to that, they could have gotten very, very ill or could even have killed them. And so managing how to keep people safe. And of course, in a return to the moon scenario, we're looking at environments that maybe they could dig under the ground and shelter, or maybe you could design the spacecraft in such a way that they have a way to shelter from this, what we call space weather. On Mars, you are continuously just left open to the space weather. Mars does not have a global magnetic field. So Mars is a huge different challenge. It's not the same thing as landing on the moon. And so I think a human presence in space, longer, more involved, more equipment, learning how to build shelters, learning how to live up there. But if something really dangerous happens, if somebody injures themselves, or say we see a huge solar storm coming, I mean, we usually have a couple days notice before it'll actually hit the Earth and the moon. The astronauts could get into a craft and just come back to the Earth. The moon is only, a couple days away, not a year. So I have to say, as a scientist, though, the thing that I think that we have neglected is sending robotic spacecraft to the moon for sample return. We really should have lunar rovers covering much of the moon's surface and then putting things in little canisters and shooting them back at Earth. And that way we would have a much greater geologic sample of the moon.
Great. Well, Eric, thank you for joining us. I know you and I love talking about space, so hopefully we'll get Michelle back again. And Michelle, thank you so much. I really appreciate it.
Nice to meet you guys. Nice to meet you, Eric. And nice to see you again, Matt.
Yep, you guys too.